Are hydrocarbons always straight chains of carbon atoms?
No. There could be carbon atoms attached to the linear chains we talked about in the previous question. Let's learn the next step in naming alkanes and have a look. First, we need to define the names of branches. See graphic, next page. Chemists use the same prefixes to indicate the length of the branch. But now the suffix is YL instead of ANA. So methane, CH4, when it's a branch off of a chain of carbon atoms, becomes methyl, CH3, ethane, CH3CH3, becomes ethyl, CH2CH3, and so on. Next we have to indicate where along the main carbon chain the branch point is. This part is pretty simple, just number the carbon atoms and put this number before the name of the branch. So if you had an 8-carbon chain, octane, with a 2-carbon branch, ethyl octane. On the third carbon from the end, it would be called 3-ethyl octane and look like this. There are a lot more rules to naming organic compounds, but that's enough for now.
Why did Gerhard Herzberg, Canada, win the Nobel Prize for Chemistry?
For his contributions to the knowledge of electronic structure and geometry of molecules, particularly free radicals. Herzberg was a famous physicist and astrophysicist, and he was awarded the Nobel Prize in Chemistry for his great achievements in molecular spectroscopy. A particular demonstration of his skill in spectroscopy was his investigations into the role of free radicals in chemical reactions. Free radicals had long been a difficult target to study, owing to their relatively short lifetimes, on the order of millionths of a second. Herzberg's talent with spectroscopy allowed him to address this and other similarly challenging and interesting problems. Why did Christian B.
Why did Paul Berg, United States, win the Nobel Prize for Chemistry?
For his fundamental studies of the biochemistry of nucleic acids, with particular regard to recombinant DNA, and Walter Gilbert, United States, and Frederick Sanger, United Kingdom, for their contributions concerning the determination of base sequences in nucleic acids. Berg earned the prize for having been the first to design a recombinant DNA molecule, which is to say he constructed a DNA molecule containing parts of DNA from different species. Gilbert and Sanger shared the other half of the award for their work toward the sequencing of DNA. The sequencing of DNA was initially an extremely time-consuming and expensive task. But today it is becoming more and more feasible to sequence DNA efficiently and affordably.
How are plastics sorted for recycling?
The first step in recycling plastics is to sort the plastics by their resin type, or resin identification code. The resin identification code is a number assigned to a plastic product or container, according to the type of polymers it is made of. While it was once common to directly use this code to identify the types of polymer, present, there are now other methods, such as near-infrared spectroscopy or density sorting approaches, that are used to sort mass quantities of plastic samples for recycling. See polymer chemistry for more information on resin identification codes.
What is a bond length?
The distance separating two chemically bonded atoms.
Why did Aaron C. Chanover, Israel, Avram Hershko, Israel, and Erwin Rose, United States, win the Nobel Prize for Chemistry?
For the discovery of ubiquitin-mediated protein degradation. While the overwhelming majority of biochemical research on proteins has focused on how they are synthesized and how they function, these three researchers took a unique path and studied how cells regulate their breakdown. They discovered that proteins are broken down and rebuilt at a much faster rate than anyone probably would have expected. Proteins are labeled when it is time for them to be broken down, and then they are chopped up into small pieces so that they no longer function.
Can elements be converted into one another?
It is possible for atoms of one element to become atoms of another element. One way this can happen is any fission process that results in the loss of one or more protons from a nucleus. The joining of two nuclei to form a single heavier nucleus is also possible, and this process is known as fusion. Both fission and fusion can result in the creation of new atoms with different numbers of protons than were present before the reaction. These processes are often difficult to control in a laboratory, however. So it's mostly only in specific cases, such as energy production, that chemists and scientists in related fields devote a lot of time to these nuclear reactions.
How do bees make honey?
The first step is searching out a flower to pick up some nectar. Nectar is a mixture of sugar and water. Specifically, the sugar in nectar used to make honey is sucrose, a disaccharide. See biochemistry. A honeybee produces enzymes in its body that can break down the sucrose into monosaccharides, fructose, and glucose, as well as gluconic acid. These sugars are the primary constituents of honey. Most of the water evaporates, which is what makes honey so viscous and sticky.
What are alternative solvents?
Alternative solvents are relatively environmentally benign solvents that can be substituted for the more hazardous choices, which, while they may be traditionally used, may have established precedents without environmental safety or toxicity concerns in mind. One such example is 2-methyl tetrahydrofuran. As a solvent, it possesses similar characteristics to the widely used dichloromethane and tetrahydrofuran solvents, but with significant environmental advantages in that it is produced from renewable feedstocks, like corn cobs and bagasse, and is easier to separate and clean up. You can compare the chemical structures of 2-methyl tetrahydrofuran. Left, with dichloromethane, center, and tetrahydrofuran, right, below.
Why does elevation matter for cooking times when I'm boiling water?
If you're boiling water in Denver, the temperature of that water will be about 5 degrees Celsius lower than if you were boiling water in Miami, because Denver is about a mile above sea level. There is less atmosphere pushing down on that pot of water than there would be at sea level. The decreased temperature that water boils at means that you'll need to increase cooking times the higher up you go.
What is a heterogeneous mixture?
A sample containing more than one substance.
What is infrared spectroscopy?
Infrared spectroscopy is carried out using somewhat higher energy electromagnetic radiation, 300 GHz to 400 THz, than microwave spectroscopy. The infrared region of the spectrum is usually a good match for the vibrational energy level spacing in molecules. So infrared spectroscopy is typically used to study the vibrational energy levels of molecules. Vibrational spectroscopy can be used to study molecules in the gas, liquid, and solid phases, as well as molecules on surfaces.
What is beta particle?
An electron created during nuclear decay reactions.
What is Coulomb's law?
Coulomb's law tells us the force experienced by a pair of separated charges. It's a fundamental equation in the study of electrostatics. which is a broad area of physics concerned with the interactions between stationary charges. The key features of Coulomb's law are that it predicts an attractive force between particles of opposite charge and that this force decreases with the square of the distance between the particles. For chemistry, it's relevant to point out that the force between charges falls off rather slowly with the distance between them, so where charges are present in relatively dense materials, like liquids and solids, they have a significant effect on their environment.
So what is molasses, then?
Molasses is the byproduct of refining sugarcane. In one of the crystallization steps, the brown liquid that is left behind is concentrated into a syrup known as molasses. The molasses you may have used in cooking or baking is from sugarcane. Sugar beet molasses has a lot of other chemicals and it tastes terrible to us. Not everyone seems to mind, though it's a common additive to animal feed.
What is a stereochemistry?
Relative arrangement of atoms of a molecule in 3D space, see also stereoisomer, enantiomer, diastereomer.
What makes fish smell fishy?
Fresh fish doesn't smell fishy at all. It's only when proteins and amino acids in fish start to break down, releasing stinky nitrogen and sulfur compounds, that the funk sets in. There are a few reasons that this sort of smelly decay is more common with fish than with chicken, beef, or pork. Fish frequently eat other fish, so their digestive systems contains enzymes that can break down the proteins found in fish. So if some of these enzymes leak out, or if you're slow to gut your fish, those enzymes will go to work on its own flesh. Fish also generally have higher levels of unsaturated fats, which are less stable than saturated fats to oxidation. Acids, like lemon juice, can slow the enzymes down, and convert the amines into less odorous ammonium salts. Which is probably why we're all used to squeezing a lemon wedge on fish.
What is fusion?
The joining of two, or more, atoms.
Why did Henri Moissac, France, win the Nobel Prize for Chemistry?
For the investigation and isolation of the element fluorine, and for electric furnace called after him. Moissac was the first to make fluorine gas, F2. which he did by passing an electric current through a solution of KHF2 in liquid HF. The second part of the committee's statement relates to his work on an electric arc furnace, which he designed to try to make synthetic diamonds.
Why do polymorphs matter?
Different crystalline polymorphs will have different material properties and physical properties. In medicine, for example, the body may absorb some polymorphs of a drug more readily, making them more potent or more effective. Polymorphism can also change the fundamental physical properties of a material, affecting things like its conductivity and thermal stability.
What is a van der Waals radius?
The radius of an imaginary sphere that can be used to represent the effective size of an atom.
How does my ADHD medication work?
Ritalin, R, methylphenidate, is probably the most common drug for the treatment of ADHD. Attention deficit hyperactivity disorder. Ritalin, R, is a stimulant, increasing the levels of dopamine in your brain. Your brain normally releases dopamine to communicate feelings of pleasure and to increase the rate at which your neurons fire, which is supposed to help you focus.
What is precision?
Precision describes how reproducible a measurement is, regardless of whether the observed value matches the true value. Measurements can be very precise even if they are not perfectly accurate. For example, if you weighed yourself on a scale that was offset by 5 kilograms, you would always be off by the same amount, but you would not be measuring your real weight. So despite not being accurate, the value you obtain could still be very precise. This will generally be true in situations involving a systematic error that is simply a constant offset from the actual value.
How can I make invisible ink?
Chemistry principles encountered in this experiment. Evaporation combustion reactions acid/base reactions materials you'll need, cotton swab or paintbrush heat source. Can be a light bulb, measuring cup paper baking soda water grape juice, optional, the procedure. To prepare the ink, just mix equal volumes of water and baking soda and stir well. Take a cotton swab, paintbrush, toothpick, or something similar, and write a message on a piece of white paper using the water and baking soda mixture you have prepared. Allow the ink time to dry. The water will soak into the paper and eventually evaporate. But the baking soda will not evaporate and it will be left behind. To read your invisible message, there are a couple of options. One is that you can hold the paper to a heat source, such as a light bulb or gentle flame. Don't burn the paper. This should cause the baking soda on the paper to turn brown, revealing your message. The baking soda burns faster than the paper, which is why it turns brown before the paper does. Another option is to spread purple grape juice over the paper. You can use a paintbrush to do this. The message should appear in a different color/shade compared to the rest of the paper. This works because an acid in the grape juice reacts with the sodium bicarbonate that you used to write your message.
What is homogenized milk?
Homogenized milk is milk that won't separate. Normally cream will separate out from milk, forming a layer at the top of the bottle. This is obviously not ideal, so to prevent this separation from happening, milk is treated with pressure to break up the little clusters of fat into much tinier pieces. These tiny globules of fat don't recombine at an appreciable rate, so the milk remains a single layer throughout its shelf life.
How many different chemical substances have been discovered?
According to the Chemical Abstracts Service, CA, which is the world's largest authority for chemical information, the 70 millionth chemical compound was recently registered, announced December 2012. Today, new chemicals are being discovered and registered at a staggering rate. The 60 millionth chemical was registered only 18 months earlier.
What is osmometry?
The process/study of measuring the osmotic strength of a solution.
What is a crystal lattice?
Crystalline solids have regular, repeating arrangements of atoms or molecules. In order to classify these arrangements, chemists use a three-dimensional lattice to encompass the smallest repeat unit, known as the unit cell, of the crystal structure. There is really a lot of math involved, but we can explain it visually. A unit cell is really just a tiny box containing some atoms or molecules. We draw the edges of this small box so that if you were to line up lots of identical copies of this box in all directions, you would get the structure of the entire crystal lattice.
What is a molecular formula?
The type and number of atoms in a molecule, Unlike empirical formula, the ratios are not reduced.
What is a cathode?
Electrode where reduction occurs.
What is the difference between a qualitative and a quantitative observation?
Quantitative observations are, as the name suggests, observations that attempt to quantify how much of something there is. Chemists are often interested in measuring concentrations of chemical species. The amount of energy released in a reaction, the lengths of chemical bonds, and numerical values associated with a multitude of other chemical properties. A few examples of measurements an analytical chemist might make are determining how much fat is in a cookie. About 10 grams, how much CO2 is in the air, about 390 ppm, or how much lead is in your drinking water. Hopefully very little. Qualitative observations are observations that tell about a general property of an object, but don't quantify exactly how much of something there is. Typically this means the observation isn't giving a number of something, but rather it is describing a quality of an object. Examples might be that a piece of candy tastes sweet, that the sky is blue, or that a circle is round. Some observations can be tough to classify as strictly qualitative or strictly quantitative. For example, a judge at the Olympic Games may assign a score of 9.5 to a gymnastics performance, indicating that she really liked it. Quantitatively, this allows for a comparison among the different competitors, but it still feels somewhat qualitative since it reflects a judge's opinion and could be influenced by factors like how carefully the judge observed the performance, what elements of a gymnastics routine the judge values the most, or even just by the judge's mood.
Why do NMR instruments use big magnets?
The purpose of using big magnets is, not surprisingly, to establish a strong, uniform magnetic field in the spectrometer. This creates an energy difference for the nuclear spins that are aligned either with or against the magnetic field. It is this energy difference that is being measured in an NMR spectrum, which can be related to molecular properties like the electron density surrounding a given nucleus.
What is an elimination reaction?
If an addition reaction adds two groups to a molecule, then an elimination reaction takes them away. The textbook example again involves carbon-carbon double bonds. But this time we're making that double bond. A molecule of base, hydroxide ion, O, causes the elimination of HBr. In this case, the process happens in one step, as shown.
What is removed from butter to make clarified butter?
Proteins and water. Clarified butter is made by melting regular butter at a low temperature. 3 layers will form. The top frothy layer contains the proteins from milk, casein. Used to make cheese, the middle layer is water with dissolved milk sugars, like lactose. The bottom layer is pure butterfat or milk fat, which is also known as clarified butter. You can instead heat butter at a low temperature for a long time to remove the water by evaporation. And then decant or filter the butterfat. Clarified butter contains almost no proteins, so it has a very long shelf life. And no lactose, so people who are lactose intolerant can eat it.
What is an element?
An element is the most basic form of a chemical substance. If you have an object made of a pure element, all of its atoms have the same number of protons. We'll discuss what this is more a little later, and the same basic chemical properties. There are not many objects that we encounter on a daily basis that are actually composed of only a single element. Most things are formed from atoms of several types of elements bonded together.
What is a formal charge?
The amount of charge, typically in integer units of electron charge, assigned to a specific atom in a molecule.
What is radiation?
The emission of energy as an electromagnetic wave.
What is mass spectrometry?
Mass spectrometry is a method of chemical analysis that involves determining the molecular mass of charged particles by measuring the mass-to-charge ratio of an ionized molecule or molecular fragment. There are several ways of performing mass spectrometry, but the general procedure involves making the sample into a vapor, ionizing the sample, and then detecting the ions that form in a way that separates them according to their mass-to-charge ratio. After being ionized, the molecules in the sample will often fragment into smaller ions, and these too are detected according to their mass-to-charge ratio. This technique can be useful for carrying out an accurate determination of the mass of a molecule, as well as for obtaining structural information about molecules via their fragmentation patterns. It also allows the elemental composition of a sample to be determined.
What is gene therapy?
Gene therapy is a method of medical treatment that tries to correct defective or disease-causing genes. There are a few ways that this may be attempted, all of which are centered around getting a normal, functional copy of the gene inserted into the genome. Some methods involve repairing the mutated gene, while others involve just adding a working copy of the gene into a non-specific location in the genome.
What is an enzyme?
A protein-based molecule that acts as a catalyst.
What is a polydentate ligand?
A polydentate ligand is a ligand that coordinates to a metal center via two or more atoms, forming two or more bonds. This resulting complex is known as a chelate complex.
Why did Paul D. Boyer, United States, and John E. Walker, United Kingdom, win the Nobel Prize for Chemistry?
For their elucidation of the enzymatic mechanism underlying the synthesis of adenosine triphosphate, ATP, and Jens Skou, Denmark, for the first discovery of an ion-transporting enzyme, Na+, K+AT-PASE. Boyer and Walker shared half of this prize for their work to understand how ATP synthase, an enzyme, catalyzes the formation of ATP. This information bears a crucial relationship to understanding how energy is stored, transferred, and used in cells. Skou received the other half of the prize for his work to discover the first ion-transporting enzyme, which is responsible for keeping the balance of sodium and potassium concentrations in cells.
What is a functional group in organic chemistry?
Functional groups are groups of atoms that tend to show similar reactivity in different molecules. Chemists use these groupings to help understand and predict how different molecules react with each other. And they're also used for naming compounds.
What is the zeroth law of thermodynamics?
The zeroth law of thermodynamics states that any two systems, call them A and B, that are each in thermal equilibrium with a third system, call it C, must be in thermal equilibrium with each other. Thermal equilibrium implies that the systems must have the same temperature, and therefore systems A and B must have the same temperature. This might seem totally obvious, but it is what puts our use of thermometers To compare the temperatures of different objects on a sound footing. If object C is our thermometer, we can use it to compare the temperatures of other objects.
What is a hydrogen bond?
Interaction between a hydrogen atom bonded to a highly electronegative atom and a Lewis basic atom.
What is a product?
Substance produced by a chemical reaction.
How does materials science help to improve the fuel efficiency of your car?
One way is through better tires. There are currently tires in development, made of rubber that rolls along with less resistance, which has the potential to improve gas mileage by as much as 10% just through the tires. Another way involves using special lubricants that work well at a wider range of temperatures, allowing for better fuel efficiency even when the engine is cold as well as when it's warm. This also has the potential to improve fuel efficiency by about 6%. Additionally, materials science is also the field responsible for developing lightweight materials to construct all of the components of a vehicle, which further contributes to improving vehicle fuel efficiency.
How much error is associated with electronic structure theory calculations?
There can be a pretty large amount of error associated with these calculations. And the main goal is to keep the errors as consistent as possible and to obtain properties via differences in calculations. For example, the energy of the metal-carbon bond in Cr(Co)6 would be calculated by comparing the energy calculated for Cr(Co)6 to that calculated for Cr(Co)5 and Co separated from one another at infinite distance.
What is a Lewis structure?
A writing convention in which valence electrons are represented as dots and chemical bonds are represented by lines between atoms.
Why does the fifth principle of green chemistry seek to avoid the use of auxiliaries?
Ideally, one would minimize the use of auxiliary substances used in a chemical synthesis, since doing so would generally be expected to reduce the amount of waste produced, thus minimizing the potential for environmental hazards.
What makes a fabric waterproof?
One type of waterproof fabric is waterproof simply because the threads are woven so tightly that water cannot easily get inside or through. Other waterproof materials are waterproof because they have been treated with a rubber or some other coating that keeps water out. Some coatings will only temporarily waterproof a material such that the coating or treatment wears away over time and needs to be reapplied.
What is an atomic radius?
Half the distance between nuclei of the same element.
What are some common structures/geometries for molecules?
The study of chemistry has benefited greatly from knowledge of properties relating to the geometries and, especially, the symmetries of molecules. To get a sense of what shapes molecules adopt, it's worth taking a look at a few of the geometries that come up often in the study of chemistry. One commonly encountered geometry is that of a tetrahedron. Methane has the molecular formula CH4 and exists in a tetrahedral geometry, with angles of approximately 109 degrees between each pair of CH bonds. Linear geometries are also relatively common. Carbon dioxide has the molecular formula Co2 and exists in a linear geometry with a 180-degree angle between the co-bonds. One last geometry we'll look at here is a planar geometry. The molecule BH3 provides one example of a planar geometry. And in this case the BH bonds are separated by angles of 120 degrees. There are also planar molecules with 4 bonds in a plane. And in those cases the bonds are separated by angles of 90 degrees.
Is there a reason all amino acids in biological systems share the same chirality?
While the answer to this question is uncertain, there have been some interesting developments in this area. It has been shown that life, as it exists today anyway, cannot arise from a racemic mixture of amino acids because the presence of chiral centers in many biomolecules is crucial for biological function. The self-replication of DNA relies on the presence of chiral centers and without a shared chirality, the error rate in DNA replication would cause severe problems for many longer-lived plants and animals. One hypothesis for the origin of chirality is that molecules from outer space reached Earth with a net chirality already present. Another is that the net chirality in amino acids was established on Earth in a very short period of time. It's a pretty interesting thing to think about, and this topic is a subject of ongoing research and debate.
What is electronegativity?
a measure describing how strongly atoms attract electrons.
Why do some prescription pills come in such elaborate colors/capsules?
There's no chemical reason for this. Sometimes pills are colored for branding purposes. Pepto-Bismol, R, is pink. Viagra, R, is blue. Cymbalta, R, is green, and you recognize those colors. It can also help people keep track of which pill is which, and also to remember which ones to take.
Why did Elias James Corey, United States, win the Nobel Prize for Chemistry?
For his development of the theory and methodology of organic synthesis. Corey was awarded the Nobel Prize for his numerous important contributions to organic synthesis, including the development of theories and methods that allow for the production of biologically active natural products. This led to many pharmaceuticals becoming commercially available, and thus had a clear impact on the general public health. His research was likely so successful because he developed the principles of a methodology known as retrosynthetic analysis, in which one starts with the structure of the target molecule and analyzes in reverse order what bonds must be broken to generate simpler structures that one can already synthesize readily.
What is a black hole?
A black hole is a region of space where the gravitational pull is so strong that nothing, including light, can escape. The size of the black hole is sometimes described by an imaginary surface called the event horizon, beyond which nothing will be able to escape the gravitational pull.
What is spectroscopy?
Spectroscopy is a branch of science associated with using light to study transitions between energy levels. Not all scientists who use spectroscopy, spectroscopists, are physical chemists. Though physical chemists, and physicists, are typically the people who develop new spectroscopic methods and experimentally investigate the details of how light interacts with matter. Data collected in spectroscopic experiments is typically presented as some response of an atomic or molecular system as a function of frequency/wavelength or time. When the response is plotted as a function of frequency/wavelength, it is called a spectrum.
How much energy is produced from a given amount of coal, oil, or gas?
1 ton of coal can produce 6,182 kilowatt-hour of energy. 1 barrel of oil can produce 1,699 kilowatt-hour of energy. 1 cubic foot of gas can produce 0.3 kilowatt-hour of energy. How much does it cost to produce energy from gas? Coal, solar energy, etc. If 1 ton of coal costs $36, which gives an energy cost of $0.006 per kilowatt-hour, and 1 barrel of oil costs $70, which gives an energy cost of 5 cents per kilowatt-hour, and 1 cubic foot of gas costs $0.008, which gives an energy cost of 3 cents per kilowatt-hour, then a 4 kilowatt solar panel system providing energy for an average ranch-style home and costing $25,000 and lasting about 20 years would provide about 120,000 kilowatt-hour for the life of the system, depending on climate, and cost about 21 cents per kilowatt-hour. You can see that solar power is still currently more expensive than other fuel sources.
What is the Avogadro's number?
The number of particles in 1 mole, 6.022 x 1023.
What is microwave spectroscopy?
Microwave spectroscopy, as the name implies, is spectroscopy carried out using electromagnetic radiation in the microwave region of the spectrum, 0.3 to 300 GHz. The energies associated with microwaves are relatively low, and these energies are typically a good match for energy level spacing between the different rotational levels of molecules. Thus, microwave spectroscopy is typically used to study the rotational energy levels of molecules. The rotational energy levels of molecules are typically studied in the gas phase.
What is aerogel?
Aerogels are materials that are very similar to normal gels, except for the key detail that the liquid component has been replaced with a gas. Since liquids were such a large component of gels by weight, aerogels are very lightweight. This type of material is translucent and has been given nicknames like solid smoke or solid air. It is produced by extracting the liquid component from a gel using a process called supercritical drying, which allows the liquid to be evaporated away without causing the solid network of chemical bonds to collapse. Aerogels have been produced from a variety of materials including alumina, silica, chromia, and tin dioxide.
What affects melting and boiling points of chemical compounds?
Intermolecular, between molecules, forces govern the melting point of a chemical substance. These include van der Waals interactions, dipole-dipole interactions, hydrogen bonding. and, in the case of ionic compounds or ionic solutions, ionic bonds or Coulombic interactions. The stronger the intermolecular forces between the molecules in a solid, the harder they will be to melt, so stronger intermolecular forces lead to higher melting points. The same is true with boiling points. Stronger intermolecular forces make the molecules harder to separate, leading to higher boiling points. For solids, the shape of a molecule can also affect its ability to pack into an ordered lattice. Having a shape that allows a well-ordered lattice to form will tend to stabilize the solid phase of a compound, leading to a higher melting point. The shape of a molecule can also affect the boiling point of a compound. In liquids that are able to form hydrogen bonds, the location of the hydrogen bond donor or acceptor can affect its spatial availability to serve as a donor or acceptor. In organic liquids, where van der Waals interactions are important, molecules with larger surface areas will have stronger van der Waals interactions, leading to a higher boiling point.
What is a nucleophile?
A molecule that donates an electron pair, i.e., a Lewis base, to an electrophile, i.e., a Lewis acid, forming a bond.
What's in Jello, R, that makes it so jiggly?
Gelatin, which is a convenient and pleasant term for the mixture of proteins and shorter peptides that are obtained from boiling byproducts of the meat and leather industries. Mostly bones and pig skin, makes Jello, R, jiggly. The hydrogen bonds between peptide strands allows gelatin to form a network in the presence of water, which is what the physical structure of the gel is that you are familiar with. These hydrogen bonds can be disrupted with heat, which is why you boil Jello, R, before pouring it into a mold. Once it cools back down, the network reforms in whatever shape the liquid is in.
Can molecules have any arbitrary energy?
No, molecules actually have a discrete number of possible energy levels. Another way to say this is that their energies are quantized. To illustrate why this is so different from situations we're used to in everyday life, consider what happens when you're throwing a baseball. You could throw it at any speed between 0 meters per second m/s, and however fast you are capable of throwing it. In molecules, though, only a discrete set of energies are possible. It's as if you could throw the baseball either 2 m/s or 40 m/s. But not 20 m/s or any other speed in between. There aren't many situations we encounter in everyday life in which the possible energies associated with objects come in a discrete set of values.
What is a gram?
One slash 1000 of a kilogram, which is the standard unit for mass.
Is it true that coffee can help you to sober up faster?
Unfortunately, no. Intoxication is related to the amount of alcohol, ethanol, in your body. And the quantity of alcohol will only decrease as your liver works to metabolize the liquor. Drinking caffeine won't really do much to accelerate your liver function. So coffee cannot, in fact, sober you up. It may help you to stay more awake or alert, but you'll still be intoxicated.
What is the difference between paramagnetic and diamagnetic complexes?
In chemistry, atoms, or molecules that have at least one unpaired electron. So there is a net spin to the molecule, are known as paramagnetic. If all electrons are paired, chemists refer to the compound as diamagnetic. When a magnetic field is applied, a paramagnetic substance will be attracted to the field, while diamagnetic molecules will be repelled from the field.
How is the frequency of electromagnetic radiation related to its energy?
The frequency of a photon is related to its energy, E, by a pretty straightforward equation. E equals h. In this equation, h is Planck's constant, which has a value of 6.626 x 10 to 34 Js. The frequency term is the frequency of the radiation in Hertz. As we can see from this equation, electromagnetic radiation with higher frequency has higher energy associated with it. When a photon's energy matches the energy spacing between two energy levels in an atom or molecule, it can cause a transition between these energy levels. This results in absorption of the photon, which transfers its energy to the atom or molecule. For example, the energy spacing between the ground and first excited electronic states of a hydrogen atom is 1.64 x 10 to 18 J, which corresponds to a photon frequency of 2.47 x 1015 Hz. So photons with this frequency can excite the electron in a hydrogen atom from the ground to first excited electronic state.
What's in toothpaste that makes our teeth cleaner?
If you get your teeth whitened at the dentist or buy some over-the-counter whitening products, the active ingredient is usually hydrogen peroxide. The hydrogen peroxide reacts with the colored molecules that are staining your teeth to remove them or at least make them colorless. This can be a slow reaction, so at the dentist's office, sometimes they use a bright light to speed Up the breakdown of the H2O2. If you're wondering about whitening toothpastes, those contain an abrasive compound that simply rubs the stain molecules off of your teeth. No fancy chemistry at all.
What is a physical change?
A change in the macroscopic properties of a substance without a change in its chemical composition.
What is the average kinetic energy of a molecule?
The average kinetic energy of a molecule is closely related to the temperature of its environment. And this determines how fast the molecule is moving. On average, the speed of any molecule is close to 300 m/s, which is equivalent to covering the distance of a few football fields every second. The other important thing to realize, though, is that collisions with other molecules are constantly causing changes in direction, which slows the overall distance in a given direction that a molecule travels.
Why did Heinrich Otto Wieland, Germany, win the Nobel Prize for Chemistry?
For his investigations of the constitution of the bile acids and related substances. The bile acids are a set of steroid acids whose synthesis begins in the liver with the production of chloric acid, chenodeoxycholic acid, all of which derive from cholesterol. Wieland isolated and determined the structure of a number of these biochemically significant compounds. During his career he also isolated toxins from poisonous frogs and mushrooms.
How do you use pH paper?
Another way of measuring the pH of a solution is with pH paper. This is a paper strip that contains a chemical indicator that changes color depending on the pH of a solution. And it can be capable of determining a very wide range of pH values. To properly use pH paper, it should not be dipped directly into the solution, but rather a drop of the solution should be placed on the pH paper. It can then be held next to a gradient color scale to obtain a pH value. Since this relies on visible color changes, it isn't the most accurate method of determining pH. But it can be a useful tool in the lab for getting a quick estimate of the pH of a solution.
Why did Alan J. Heeger, United States, Alan G. McDermott, United States/New Zealand, and Hideki Shirakawa, Japan, win the Nobel Prize for Chemistry?
For their discovery and development of conductive polymers. This prize was awarded for the discovery of plastics/polymers that can, under certain circumstances, be made conductive. This was quite a surprising result, since nobody ever expected plastics to be conductive materials. These plastics/polymers consist of chains of conjugated carbon-carbon double bonds. In other words, carbon-carbon double bonds that alternate with carbon-carbon single bonds. These polymers were also doped, which means that electrons were either removed or added artificially by oxidation or reduction.
What causes the tides in the ocean?
The ocean tides are caused by the gravitational forces between the Earth, the Sun, and the Moon, along with the centrifugal force imposed by the Earth's rotation. As the Earth rotates, and as the three bodies move relative to one another, the gradual and recurring shifts in the balance of gravitational forces cause the water in the oceans to tend to move toward one coast or the other.
What is a laser?
A laser is a light source that emits light amplified through the stimulated emission of photons. The acronym, laser, actually stands for light amplification by stimulated emission of radiation. Lasers come in many shapes and sizes. Some can fit in your pocket, and some are huge and take up entire rooms. Some emit pulses of light, while others emit continuous beams of light. Since there are so many types of lasers, it's not surprising that they find wide-ranging applications from simply pointing at a screen during a presentation to carrying out complex measurements in physics and chemistry experiments.
What is a Lewis base?
A molecular that can donate a pair of electrons.
What is a kilowatt hour?
A kilowatt hour, is a unit of energy representing the amount of work that is done by 1,000 watts of power operating for 1 hour. Notice that a watt represents a quantity of energy per unit time, also referred to as power, while a kilowatt hour simply represents a quantity of energy.
What is Le Chatelier's principle?
Le Chatelier's principle tells us how to predict the effect a change in conditions will have on a chemical equilibrium. It tells us that a system at equilibrium will shift to counteract changes that disturb the equilibrium. These could be changes in concentrations of chemical species, temperature, pressure, or other conditions. The most commonly discussed changes involve changes in concentration of chemical species. So we'll just focus on those here. For this equilibrium, A and B, D, C and D, if we decrease the concentration of A, some C and D will react to replenish the A that is depleted, so the concentrations of C and D will decrease. As species A is replenished, more B will be created as well. So the net effect is that decreasing the concentration of A will also decrease the concentrations of C and D, and at the same time increase the concentration of B. More generally, decreasing the concentration of a reactant will cause the equilibrium to shift toward the reactants. Increasing the concentrations of other reactants and decreasing the concentrations of products. The converse is also true, decreasing the concentration of a product will cause the equilibrium to shift toward the products. Increasing the concentrations of other products and decreasing the concentrations of reactants. It is important to keep in mind that Le Chatelier's principle only applies to reversible chemical processes. Chemical equilibria. So everything we have said here does not apply to reactions that can only proceed in the forward direction.
What's hair made of?
Keratin is the major component of hair and nails. It's a protein that makes up the outer layer of your skin, your hair, fingernails, and toenails. Actually, keratin is everywhere in the animal world, the hooves, claws, and horns of most mammals, the scales of reptiles, the shells of turtles, and the feathers, beaks, and claws of birds. Many copies of this protein molecule assemble into a large helical structure that provides the structure and rigidity to the material. Keratin proteins contain lots of sulfur atoms in the form of cysteine amino acid residues. These sulfur atoms can form linkages between keratin strands and between the larger helices that are formed, leading ultimately to a curling of the hair strand. Yep, you guessed it, the more disulfide bonds there are, the curlier your hair will be. Hair straighteners work by breaking these disulfide bonds, relaxing the hair to a straight conformation.